Hi all, this is Amardeep Srivastava, and in this question I'm going to explain you all about, or through this question, through such type of question, I'm going to start about a lecture series on my channel GATE UPSC Simplified, in which I will solve conventional question, that is for electrical engineering optional papers. I will solve conventional paper from various sources. I can use, or I will use, like different sources for conventional solution. Like I will use civil services examination, electrical optional conventional paper previous year question for this series. Also I will use engineering services examination conventional paper series, as well as apart from these two I will use the basic standard textbooks solved as well as unsolved problem from various sections of different subjects, like for analog electronics, for power system, electrical machine, power electronics, and for all the papers I will try to complete this segment. And most of the questions that I will take will be mainly from civil services examination as well as engineering services examination previous year question. You will find it very interesting if you will go in deep dive with these type of questions. Like in case of engineering services and civil services examination, the standard and level of question were very high and very good. You will find in the at most of the text find those type of standard question in most of the textbook, and I find it very helpful as well as very interesting. Now let's start with, I have started with analog electronic circuits, and in an analog electronic circuit I have used first question as the diode question. This is the Indian Civil Services exam 2016 10 marks question, and in this question they have given that there are two identical diodes, there are two identical as well as ideal junction diodes connected as shown in the figure. Now it is also given that if the current through the reverse bias diode is I naught, given that there is a current that will flow through a diode which will be reversed and its value is I naught and it is constant. Okay, now we will have to explain, it is given, they have asked in the question that explain the circuit operation when both the diodes are connected in forward bias condition. Okay, we have to generate the conditions for which both the diodes are connected in forward bias condition. ठीक है, अब इसमें given क्या क्या है, VT दिया हुआ है 25 millivolt, V gamma, the cutting voltage is 0.7 volt and eta is 1 for diodes. ठीक है, स्टार्ट करते हैं इसको सॉल्व करने का. सबसे बेसिक चीज हम ये जानते हैं कि कंडीशंस गिवन क्या क्या है. फर्स्ट कंडीशन गिवन इज दैट द बोथ द डायोड्स आर आइडियल एंड आइडेंटिकल जंक्शन डायोड. ठीक है, ठीक है. अब देखो V वोल्ट अप्लाइड है 50 मिली वोल्ट अक्रॉस दिस सिस्टम, अक्रॉस दिस इंटरकनेक्टेड डायोड. तो जैसे अप्लाइड वोल्टेज V क्या कर देगा, D1 as this positive terminal, this is negative terminal. This positive terminal will make this diode D1 as a reverse bias diode, as a reverse bias, and this negative terminal which is connected to the negative part of diode D2, it will make this diode to conduct. Okay, so the applied voltage is V1. So for the applied voltage V is equals to 50 millivolt. D1 will be reverse bias, ये डायोड जो होगा वो रिवर्स बायस में होगा, एंड D2 विल बी इन फॉरवर्ड बायस. सिंपल, नथिंग टू थिंक much for this condition because they have already mentioned the factor that the D1 will be in reverse bias because of the polarity of this junction voltages. Like that, this positive terminal is connected to negative part of this diode D1. This negative part is connected, this negative terminal of this EMF battery source is connected to the negative part of this diode D2. So D2 will be in forward bias and D1 will be in reverse bias. So the condition is that if diode is in reverse bias, there is a current, the reverse bias diode, there is a reverse bias current I naught which is constant. So you can say that ID will be nearly equals to I naught for this condition. but we know that for diode 2 as it is in forward bias condition, diode 2 जो है वो forward bias condition में, सो आप कह सकते हो कि diode D2 के लिए करंट क्या हो जाएगा, ID is equals to, as we know that for a diode current is given as ID equals to I naught e to the power Vd by eta Vt minus 1. We all know this. This is a basic diode equation. We all are very much acquainted with this equation. Now, this is the most generalized equation for diode equation. Okay, this is diode equation. Okay, now this equation for D2, what you will write it as ID is equals to I naught, okay, e to the power V2 by Vt, as eta is given as 1, so we will directly use it as 1 minus 1. I am not putting any value because it will reduce the complexity. अगर मैं यहाँ पे वैल्यू पुट कर दूं तो फिर कॉम्प्लेक्सिटी बढ़ जाएगी, क्योंकि क्वेश्चन थोड़ा सा, अगर कन्वेंशनल क्वेश्चन है 10 मार्क्स का क्वेश्चन है तो वी विल हैव टू एक्सप्लेन बिट बाय बिट एवरी बिट ऑफ दैट. ओके, सो नाउ as in this diode D1 is reverse bias and D2 is in forward bias, so you can write the equation is as, now for D1 what you will write it for D1, you can write it for D1 that a diode equation will be what, I naught, as it is in reverse bias there is a saturation current will flow, it is given as 1 minus e to the power minus V1 by Vt. The direction will be opposite to the direction of the current that is flowing in the D2. Okay, now you can say that both the diodes are connected in a series fashion, but they have been placed in such a manner that the current across diode D1 is flowing like this, and the same current and the current in the reverse directions flowing like this in D1. If any current will flow in D1, it will flow like this. Okay, so on equating equation what you will get as I naught, because the current magnitude will be same but the direction will be reversed, hence for the direction reversal we have written 1 minus e to the power minus eta Vd by eta Vt, that is I have already considered the negative sign inside, so you can write it as I naught e to the power V2 by Vt minus 1. I have done nothing. I have used just these two equations because the current will flow with the same magnitude but opposite in direction. Okay, with the same diode. So I naught 1 minus e to the power minus V1 by Vt. तो इतना तो हम लिख सकते हैं easily. ठीक है. So now what you will get on further reduction from this is that I naught will be cancelled out. Okay. This one will be not cancel out because this will be in additive polarity, so you can write it as e to the power V2 by Vt. Okay, this इसको यहां ले आते हैं e to the power minus V1 by Vt. ठीक है, इस वन को इधर ले जाते हैं, ये हो जाएगा 2. ठीक है. नाउ अब एक कंडीशन और हम लोग जानते हैं कि जो भी क्युमुलेटिव सम होगा इस दोनों पे के क्रॉस वोल्टेज का, वो उसका सम तो ऑब्वियस है 50 मिली वोल्ट ही आने वाला है. सो यू कैन राइट इट एज V1 प्लस V2 इज इक्वल्स टू 50 मिली वोल्ट लिख सकते हैं. ठीक है. अब देखो इस इक्वेशन में दो वेरिएबल है, एक इक्वेशन हमारे पास, तो हमको रिप्लेस करना होगा एक वेरिएबल को. तो एक सेकंड इक्वेशन तो मेरे पास ये आ गया. ठीक है, कौन सा आ गया, V1 प्लस V2 इक्वल्स टू 50 मिली वोल्ट, और एक कंडीशन हमारे पास ये है. ठीक है, तो हम लोग क्या करेंगे, इस इक्वेशन में इसको सब्स्टिट्यूट करते हैं. चलिए ठीक है, सब्स्टिट्यूट करते हैं कैसे, तो V2 यहां से रिड्यूस कर लेते हैं. V2 क्या हो जाएगा, 50 मिली वोल्ट है 10 टू द पावर माइनस 3 माइनस V1 हम लिख सकते हैं यहां पे, नो डाउट इन दैट. ठीक है, अब हम क्या करते हैं, यहां से इसको रिप्लेस कर देते हैं इस इक्वेशन में, कर सकते हैं. तो क्या हो जाएगा, e टू द पावर V2 इज व्हाट 50 इंटू 10 टू द पावर माइनस 3 माइनस ऑफ V1 by Vt, ठीक है, प्लस e to the power minus V1 by Vt is equals to 2. You can write this equation like this, ठीक है. Now moving further, what you will get on solving this function as e to the power 50 into 1 by 1000 by Vt into e to the power minus V1 by Vt. I am just splitting the factor, exponential factor, as per my convenience, so that it will be easy for me to solve this exponential equation. Okay, I am doing nothing here. Okay, now what you will get it as, on further reducing, on further solving, you will get minus V1 by Vt minus V1 by Vt. This will, if you take common, okay, so it will come as e to the power minus V1 by Vt, okay, into e square plus 1, okay, is equals to 2. Okay, now what you will get from E1 by Vt, now on further solving, what you will get as e to the power minus V1 by Vt is equals to 2 by e square plus 1. I have done nothing, I have just shifted these factor to this factor. Okay, now on solving by using the CalC, I'm using CalC FX991 IES as 2 divided by e square, 2 divided by e square minus of plus of 1, I am getting as 0.2384. okay, so it will come as 0.2384. okay, now as we know what we have calculated, e to the power minus V1 by Vt we have calculated, then you can put this factor in as id is equals to I naught 1 minus e to the power minus V1 by Vt. For diode D1, I have already mentioned this. I have used those factors in equation 2. Okay, so what you will get as id is equals to I naught into 1 minus 0.2384. What I have used? I have used this factor in here simply for the simplification. So what you will get as I naught 1 minus 0.2384 is 1.0. You will get nearly 0.7614. Okay, id equals to. Okay, now we will talk about the condition. As in the question it is given that we will have to explain the circuit operation when both the diodes are connected in forward bias condition. Now, taking the consideration of the condition given, we will take when both the diodes in forward bias. Simple concept, you will take this diode D1, this diode D2, okay, connected with the same polarity, 50 millivolt, okay, plus minus V1 plus minus V2, both are in forward bias condition. ठीक है, this is D1 and this is D2. Now I am moving forward as per the question concerned. Okay, now in the same circuit it will also V1 plus V2 will be equals to 50 millivolt. Now as both are connected in the similar fashion, both are identical diode, and also they are ideal and identical, so we can say that V1 equals to V2. So 2V1 equals to 50 millivolt. So V1 is equals to V2 is equals to 25 millivolt, we can say. Okay, so now using this condition simply, what you will get as ID equals to I naught e to the power V1 by eta Vt minus of 1. What you will get as I naught e to the power V1 is what? V1 is 25 millivolt by Vt is also given as 25 millivolt. For the sake of simplicity, I have used directly here Vt. Vt is 25 millivolt. 25 millivolt. Okay, that's why millivolt, this condition is millivolt, this milli and milli cancelled out, so I have get it the value 2. Okay, now what will be the condition here is that e to the power 25 millivolt by 25 millivolt minus 1. ठीक है, ये कंडीशन सिंपल सा आ गया, तो ये तो फैक्टर इतना सिंपल आ गया, आई नॉट ई टू द पावर 1 माइनस 1, सिंपल. ठीक है, तो आप क्या लिख सकते हो, आई डी इक्वल्स टू e minus 1 is what? Something you have to remember, like some of the values that you need to remember, like root 3, that is 1.732, 1 by root 3 0.577, 1 by 2 pi 0.159, root 3 by 2 0.866, ln 2 0.6931, ln 3 1.086, ln 1 is 0, ln 5 is 1.0694, root 5, root 6, root 8 2.82, pi square is nearly 9.86, 1 by pi is 0.3183, 1 by pi square is 0.1041, 1 by e is 0.396, e is 2.178, log 2 root 2 by 3. These things, if you are writing electrical or if you are reading electrical, you need to remember these things because they are used frequently and you will not use calculator all the time. So it will be I naught e minus 1. What is e? E is 2.178. This factor will come as 1.178 I naught. ID equals to. So now, what are the conditions that you are referring? ID in second condition, when both the diodes are in forward bias, and what you have get when one diode is reversed and one is forward, ID as this. So there is a difference. So you can say that what is the question they are asking is that reverse bias diode is I naught and it's constant. Explain the circuit operation when both the diodes are connected in forward bias condition. So you can say that ID is 0.7614 of I naught times when one of the diode is reverse bias and second diode is in forward bias. When both the diodes are conducting, that is in forward bias, you are getting as ID 1.178 of I naught. That is ID value is gradually increasing. So you can say that these conditions you can justify. As of the question is of 10 marks, you need to explain this much only. I think this much will be more than sufficient and more than enough for as per me. Now if you want that I should post this solution of these questions also, you can join the Telegram channel of my conventional electrical questions. I have already created on Telegram, UPSC EE optional, but I will give you the link in the description box or in the comment section. You can join this. It will be beneficial for you. I will try to post daily 1 or 2 questions from civil services or engineering services as well as for standard textbook that will match the level of these conventional paper. You can also use these conventional type paper if you have any exam in which electrical subjects you have taken it as an optional. Thank you so much. Stay connected. If you want the notes, if you want this question PDF, you have to join the Telegram channel with the same name.